Start video. Well, hello everyone. Thanks for joining us for this solar webinar. Let's call it Rooftop Solar Webinar. So that's an important distinction to make. We're not going to talk about just solar, and we're not going to talk about just roofing. We're going to kind of combine those two topics into a rooftop solar webinar. So just a quick introduction. My name's Ron Harriman, and I'm with Benchmark, and I wear a lot of different hats here at Benchmark, and try to do some roof consulting with keeping our team on board and working hard and covering the United States. So we're really glad to be here with you today, and I'll tell you a little bit more about Benchmark as we go, but really not going to spend too much time on that. So today's goal, really, let's talk about what is the goal today. Solar is a hot topic, and I guess I know that there's even maybe a temporary situation we have on the supply side, the supply chain for about every type of roof system or solar array, canning jars. Virtually every supply chain we've got going in the U.S. right now is a little bit disrupted. We're not going to talk about that too much today. We're gonna kind of hope and pray that that's kind of a temporary situation. We're going to get past that, and we're going to continue on a trajectory that is really kind of interesting to think about. In fact, some of the research that we have done indicates that the prominence of solar on rooftops will probably increase tenfold in the next 10 years. So this is something that, hey, we got to be ready for. You all have to be ready for it. So if we're going to do rooftop solar, we may as well do it well, right? So here we go. So the question, really is not just is your roof solar ready, but are you ready? So I don't mind being a little, maybe getting into the mode of challenging you with that question today. So a couple of just housekeeping items. First of all, the webinar is being recorded, so it's available to you if you so request. There is PDHs for professional development hours available. And if you have any questions, if you're having any technical difficulties with the webinar, send a quick email to Lisa Workman, who's on board and ready to help you at lworkman@benchmark-inc.com. So there'll be 2 poll questions during the webinar, and we'd love to have your input. So through the power of Zoom, go ahead and it'll just take a few seconds, give us your input. And then there is some built-in time for Q&A. In fact, we've already had some questions come in. And so let's go ahead and get started. So kind of just a broad 30,000-foot view of where we're going to go here. First of all, we're just going to share with you some of our experience, some of what we've seen working throughout the United States on roofs and where we've got that combination of solar and roof. So we'll kind of break it down in 4 areas. 1, the existing roof that has solar. You've got, and let's say another scenario B, where you've got an existing roof and you're thinking about putting solar on it. And then maybe an easier entry point is where you're getting ready to re-roof a building and you want to make sure that the roof is ready for solar. And then new construction, very similar. I won't really spend a lot of time on new construction in terms of getting ready for solar because it's so similar to being, that re-roof being ready for solar. So we're going to talk a little bit about how you go about solving issues. So what are the top solar issues and how do you best solve them? And that might be a little bit of a surprise to you at the end of the day, but we're gonna make some connections here in terms of how to be good problem solvers. And so that's where we're headed. I hope that's all right with you. So let's go ahead and get rolling. Let's start off with a poll question. So this will allow just 30 seconds or less. So please, if you could, check all that apply. You know, tell us, does your organization have rooftop solar? And then likewise, your organization, does it have published green or sustainability goals? So I'm going to just give you a few seconds to answer those. So give us your input if you would. Okay. Well, it looks like about half, almost half of you have rooftop solar. That's interesting. And then I'm not surprised, but it's probably a little bit higher than what I would have thought. 90% of you have published, your companies have published green or sustainability goals. And I think that is, you must have seen the webinar in advance. I mean, it's all over the place. And I would kind of go back in time. 20 years ago, I remember going to the NRCA convention in Las Vegas. And I left there thinking this wasn't a roofing show, it was a solar show. And in some respects, many of those products didn't work too well. In hindsight, you know, some of the thin film technology, you know, laminates, et cetera, they didn't really work that well. And more than likely, most of the growth in solar at that point in time was being based upon tax incentives. That's where we were seeing solar being invested in. Today, there's been a major shift. What's driving solar is probably, you know, there's still tax incentives that we can't, you know, certainly not going to ignore the availability of those, but to a great extent, this is being driven by your corporations. So just a couple of examples. One of my team members helped me put this together and just went out to the internet and did some quick Google searches on solar, not just solar, but green or sustainability goals. And this happens to be from Walmart. And look at the highlight here. First of all, what did they want to do in 2020 in terms of scale of renewables and accelerating efficiency of their facilities? And then Walmart's commitment to be supplied 100% by renewable energy. I mean, that is just remarkable. So here's an example from Corning. They want to be near the top of solar energy users in the U.S. Boeing, look at you know, two of their facilities in Renton, Washington, and Charleston, South Carolina, are already powered 100% by renewable energy. U.S. Foods, 13 million kilowatt hours from solar. Caterpillar, you know, major investments. And you could see the solar array on this illustration. It's on the ground. That used to be my advice to my clients was, hey, don't you have some green space somewhere? You just soon put that solar array on the ground. And but that was a little bit of my attitude, frankly, showing through. You as clients, more than likely, you've got this real estate up on your roofs. You want to put it to good use. You want to maximize it. Hey, get over it, Ron. We're going to put solar on roofs. And so, and look at General Motors. Through investment in additional 500,000 megawatt hours of solar power, GM will be able to power all of its Detroit area facilities from clean energy. So it's just a matter of, I think, you know, when we get through this and we talk about how do we solve issues, I want you to remember those corporate objectives that are out there. So, hey, just a real quick touch on Benchmark then. Basically, we work all over the United States. We're a roof consulting firm and a pavement consulting firm. That's all that we do. But we do see that solar is coming more into our world and has been for several years. So again, we're going to try and help our clients. If you're going to do it, we're not necessarily going to be the ones standing up and saying, hey, you should do it. But if you say we need to either ready this building for solar or consider solar on an existing roof, we're going to try and help you do that to the best of our ability. This is a shot of our staff back a couple of years ago when we could gather all together and didn't have to be concerned about that. And I can tell you that we're really looking forward to being able to gather in person again. And you know, in little bit about Benchmark, we really concentrate on three things. One, being technically excellent, taking really good care of our customers. And then the third thing we focus on is organizational health. And when I say that, you know, in essence, the trust and the relationships that we have within our company basically enable us to do a good job of taking care of our customers and being technically excellent. It sounds like, you know, that's kind of the Benchmark secret sauce in essence. We really concentrate on that, and we're going to work harder on it even going to the future. So, hey, let's get into the meat of the topic. So again, rooftop solar. We're going to talk now about where you've got an existing roof with solar. And I've got a couple of examples. One, a retail example where we can show some of what we've learned, an industrial example, and then a commercial example. So you can see just from that beautiful blue sky, this is probably a great place to consider solar. For one, there's a really healthy supply of sunshine. But this, in this case, the roof was about 18 years of age and had a solar array that was covering, yeah, I believe about 27% of the roof square footage. So, and the solar array was installed at the time that the roof was installed. So you can see it's what we would refer to as a ballasted assembly, where the array is basically laying on the roof. And this happens to be a PVC membrane, not necessarily a real popular membrane or a prominent material supplier, but it was certainly a player back in that day. What we're seeing here basically is the method of attachment being loose laid. The rack is sitting on these rubber blocks with PVC membrane pads underneath protecting the roof. But one of the things that we identified is some incompatibility between the PVC and the rubber blocking. So that's causing some of this staining that you're seeing. We also have seen some very common, not just this roof, but some real common problems where some of the electrical aspects of the array, you know, it's really kind of a question. Was the roofer doing electrical work or was the electrician doing roof work? We're not sure. But let's maybe as you go forward, make sure that we've got a good distinction in that area. Because when we start seeing caulking being overused, we know that that's not going to be a great long-term solution. This is a building actually in Massachusetts where you can see, if we look back in time on a Google Earth image from March of 2017, so it's the same building shown on the right in May of 2020. So in March of 2017, the roof had no solar array. In May of 2020, you can see that that roof has a partial, in part anyway, a solar array. Unfortunately, the solar team, maybe and the roof team, didn't get together on this one. The solar array was installed on top of a roof that was, you know, practically in the fourth quarter of its service life potential. Let's just say that this roof was put 20 years of age, and now we've got a new solar array put on a roof that is nearing the end of its service life. So this is a drawing of that same facility with the blue shading to the left and kind of the L shape being the solar array. So as we were hired to do a roof evaluation, we identified various defects throughout the roof. And if you kind of follow my cursor, if you can, over here to the left, you can see far left this red X. So we had leaks developing just on the perimeter of the building. Unfortunately, we also had a leak underneath the solar array. So we did an infrared scan, and we could only use the infrared in the area just outside of the array. You can't use it within the array because it, blocks the sun, and there's just too much clutter. You can't get a good line of sight. But you can see the streaking in the thermal signature here. And so, unfortunately, some of the water that's accumulating within the roof system is due to defects underneath the array. One of the things we've also seen when it comes to existing solar, and you might think that attachment is only important in high wind zones, or on the Gulf Coast or along the Atlantic. Well, this happened to be very close to our office last August. We had a storm of major proportion blow through Iowa, and this solar array ends up being basically crumpled up as a pile of junk. And so the attachment of it is important, not just in high wind zones, but it's something that we really need to think through throughout the U.S. So what are some lessons learned? I would think one of the lessons learned, if I take you back again to that time, when I went to that NRCA convention in Las Vegas about 20 years ago, one of the questions I had in my mind at that time was, hey, will these solar panels even last 20 years? If we're going to try and design the roof with that length in time, how do you know that the solar panels themselves will service that long? Well, that first example that I showed you in full, that's in Arizona, and the panels are 17 years of age, and they're doing just fine. So I think we can trust the idea that the panels themselves are, have full capability to last 20 or 25 years or even longer. Another lesson that we've learned is that foot traffic is significantly concentrated. No longer can you just cut across the roof in a variety of patterns. You're going to have concentrated areas of traffic, whether it be, in terms of servicing HVAC units or the array itself. So it's highly, highly advisable that you beef up the system design in those aisleways where it's predictable. You're going to have concentrated traffic. Compatibility of components, not a huge deal, but it's something we got to think about. Caulking, we really don't want to be relying on caulking for seals of conduits and et cetera. There's lots of good ways to work around that. So if you're going to have a roof and a solar array, you want to design some of the seals to have about the same service life expectancy. So defects causing leaks within the array, that's a very unfortunate situation. And I just want to prepare you for it, that if that happens, it's a very slow and expensive ordeal. Finding leaks within the array is difficult. Getting the, a portion of the array shut down so that you can remove panels to do the repair work. It's a very unfortunate thing. You want to do everything you can to avoid it. Moisture survey techniques are certainly limited. And I added in a preference here. This is not necessarily by the building code or any particular requirements, but the solar array will oftentimes be designed in terms of how many megawatts, how much power output do you want? So that determines the size of the array. And so rather than just blanketing the roof with as many panels as possible, I really strongly recommend that we keep the panels away from the perimeter. The perimeter is where we have the highest wind uplift forces. And so why put a sail out there next to the edge of the roof? Let's keep the panels within the field of the roof as far as we can, away from the corners, away from the perimeters. And then we're aware of a couple of different studies where the effect of the solar panels on the roof membrane itself is being studied. So in one kind of school of thought, you've got the idea that, hey, the roof is being shaded, it should last longer. But then likewise, the solar panels generate heat. Is that heat going to significantly increase or accelerate the deterioration of the roof system? So that's the study that we're keeping an eye on. So here's the second poll question. So if you could take just a couple of seconds. So if you've got solar panels on your roof, what issues have you encountered? And again, check all that apply. You know, are you having difficulty locating roof leaks? I'm sorry if you are. Increased damage due to foot traffic, reduced roof life. Have you had any displaced solar panels? More than likely due to wind, but it can also be seismic in nature. Have you noticed any type of increase in maintenance or repair costs? I'll give you just a few seconds to check all that apply. I think we've just got a few seconds left here. Okay. Difficulty locating leaks. Not even a close second, hardly. Wow. Like I say, that's when you've inherited a system with, you know, an existing roof that has an array, and now you got a problem. Wow. I mean, there's no magic bullet here. But as we go forward, we're going to kind of identify how to prepare better for that. So now we're going to move into where you're thinking about considering solar onto an existing roof. So we'll look at a deterioration curve, some cross sections, and an example. And there's a couple of slides here that I could really spend a lot of time on, and this being one. So I'll just take a little bit more time with this, but it's on here. We've got on the horizontal axis just an age profile. So going out, stretching out to 25 years, from day 0 to 25 years. Then likewise on the vertical axis, the condition. So if you think about it, day 0, the day the roof was installed, it's the very best that your roof condition probably ever was or will be. So hopefully it was designed well and installed well, and it's in very good condition. Stretching out to a service life potential of perhaps 25 years. You don't really have to do a lot of fancy design work or buy exotic materials to consider that as being at least within the realm of possibilities. But here's the reality of the low slope marketplace, a 17-year life. That's the average life of a low slope roofing system. That's how long they're lasting in the low slope marketplace today, which I think, you know, is unfortunate that it's not longer than that. You don't have to do a lot to move that curve to the right. Obviously, you need to install materials that have the capability of lasting longer than 17 years. You have to have a good contractor install them properly, manage the project, and then, you know, do a good job of maintaining them. But there's a little bit of a rub here if you think about it. With the solar system, many times having a 20 to 25 year life, and you know, all of the economics are based upon that service life. You don't want to be needing to pull that solar array off your building to re-roof it in the middle of that, because it ruins the economics. So how do we prepare for that? Okay, we're thinking about putting solar on an existing building. That vertical line that I drew right at the 5-year mark, that's our kind of line in the sand where we're going to say that if your existing roof is more than 5 years of age, you should probably not consider putting solar on it. Because what's going to happen is that you're going to end up at that midlife needing to replace the roof. And I didn't want to ask that as a poll question. It's happened. And I think to a great extent, the reason it has happened, maybe there's good reasons that it happened, But sometimes it's a matter of the solar team and the roof team not necessarily being in sync with one another. So 5 years, that's where we're going to cut it off and say, you know, and that's even pushing it in my mind. So here's an example. This roof, it looks kind of dirty, but it's in Texas and just catches a lot of you know, dust and dirt from the winds. But this roof is 1 year old, and it was built with the idea that it could be ready for solar. The client asked us to do an inspection of the roof prior to the solar array being installed. And I think it was a good thing that they did, because I think my guess is that the roofing contractor came in, installed the roof, and then a month later came the other trades. And so we ended up identifying, I'm just going to say hundreds of defects on this 1 year old roof, many of which happened after the roofing contractor left. We had punctures in the roof. We had scuffing. You can see it was an induction welded PVC membrane. We did have some seam defects. It's like all of those things, if we cover them up, we'd had that, you know, 83% of you have had trouble with leaks underneath the array. Well, you've got to treat this roof like it's got to be perfect before you install that array. So thorough inspection before you consider covering an existing roof with an array. So let's talk about the roof design. And I'll just take a little bit of time. I've got a series of slides here, but if we start with a steel deck on a commercial or industrial building, pretty common roof design here. 2 layers of isocyanurate insulation, mechanically fastened. You know, the attachment of the ISO is shown there. We don't have the attachment of the membrane shown, but let's just assume it's a mechanically fastened or induction welded PVC or TPO membrane. That's pretty common in the marketplace. Literally thousands of acres of this type of roof system going down everywhere in the United States today. I mean, that is going down. But I'm going to say this roof, which is a common roof system, a code compliant roof system, is not solar ready. And I'll kind of just show you a progression of slides here in terms of why I feel that way. But over to the right is this, I left this in, this is actually coming off of a design project, but I took the costs out because that is so variable in nature. But one of the considerations that we do need to have an awareness to is the weight of the system. So if we look at this roof design, it weighs about, if you add up the 2 layers of insulation, the membrane, it only weighs about 1.1 pounds. So certainly as you're considering going forward with the solar array on an existing roof, you do need to consider the weight of the roof system, the weight of the new panels, and then does your building have the capability to handle the weight? I'm not going to touch much more on that today, but it's really vital to the overall equation. So let's say we upgrade that same roof system. So what did we do differently? We still had that steel deck, 2 layers of insulation. Now we've added a layer called the cover board. And that cover board is mechanically fastened with, let's say, maybe a slightly thicker roof membrane. You could have instead of a 45 mil membrane or a 50 mil membrane, maybe you've upgraded to a 60 or 90 mil membrane, or even a 2-ply or bituminous built-up roof system. Something a little bit more robust. But I'm going to admit that this is an upgraded roof system. It's still not quite meeting Ron's criteria for a solar ready roof design. And so we'll just kind of keep moving that direction. So now we're going to call this solar ready. We've got that same deck, 2 layers of insulation, mechanically fastened ISO. Notice where the fasteners are. The fasteners down in that insulation layer, and then the cover board is actually adhered in ribbons of polyurethane adhesive, and then the membrane is adhered. And so what this has done for us is it's buried the fasteners. The fasteners, so we're not nearly as susceptible to scuffing. If we talked about traffic, the reason that being solar ready is kind of a concept is because of the traffic to install the system, That's high traffic. Then likewise, we've got concentrated traffic for the next 20 or 25 years after the system is installed. So by adding up all of these components, upgrading with that cover board, fully adhering the membrane, now you're officially solar ready. And I'm not going to sit here and say that mechanically fastened is, can never be done. But I think it can be, but I think that would place far more importance on the thickness of the membrane. So, and again, we've added up a little bit more weight in that weight chart, so you do have to think about that too. And then I just added a slide here in terms of what's called VSH, solar ready roof system design. So this would be a more extreme situation, but I thought it was an interesting parallel. VSH stands for very severe hail. So that's a region of the United States that's more prone to hailstorms and large hail events. And so interestingly, to design a roof properly for hail is very similar to how you would design the roof for being totally solar ready. So in this case, we've upgraded the system again. We still have that 2 layers of ISO mechanically fastened. We went to an even thicker or more robust cover board and that more robust membrane, whether it be in a fleece back membrane or bareback membrane, now being available. So hail resistance, solar ready, is sometimes fairly similar in terms of what you would do to design the roof. So for those of you that are FM insured, VSH is something you need to be really aware of in order to have Factory Mutual or FM Global insure your facilities. So this is an example where it's like, I think part of my mission in life is to keep solar off of this building. And just at a glance, you can tell that this is an aged roof system. So is it less than 5 years old? No, it's pretty obvious. This roof, in fact, this roof is over 20 years old. But the roof team for this client and the solar team are not in sync. The solar team desperately wants to put solar on this roof. And I'm just gonna have to say, no. I mean, it's not less than 5 years old. Is it in good condition? You can see some of the aging effect. No, it's not in good condition. So is it solar ready? Heck no, it's not. So think of it as a little bit of a flow chart. Age, less than 5 years old. Is the system in good condition? Yes or no? If it's less than 5, it's in good condition. System supports the demands of solar. So you've got that, go back to those cross sections. You've got a roof system that is one of those cross sections or something similar. If you're yes, 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 then you're solar ready. But if you're not, any one of them's a knockout punch. So getting ready for solar. This is an example straight out of a benchmark project. So you'll get a recording of this, and I often tell the story of a architect friend of mine who actually designed a home for me. And the first, he went through a process. We started with a blank sheet of paper, and he's asking me, okay, when you get home at night and you get out of your car, what's the first thing you're going to do? What are you going to have in your hands? So he started designing my house with, my objectives in mind. So when we start a re-roofing project design, we try and understand the client's objectives. We'll walk through this kind of list of criteria, and I just lifted this off of an actual project in Arkansas that we did a few years ago. So we looked at the history, the existing conditions, the roof system performance requirements, such as the building code, the energy code. What do we need for wind? What do we need for fire? Fire, when you think of solar, that's something we got to be concerned with. Edge metal securement, hail resistance, and is this client, what do they have for insurance? How long do they want the system to last? Huge variable. How long do you want this to last? So warranty requirements. Do you have any interest in warranty? And then we got to kind of build the project. We got to think about safety, protection, interior protection, et cetera, vapor design, noise, dust. But then now let's think about it. we've got these sustainability objectives, thinking about energy efficiency and production, solar, durability, life cycle, materials management, water management. So in other words, you know, when Greg designed my house for me, he didn't design it just to be exactly like my neighbors. And likewise, he didn't design it to be exactly like the house that he designed before that. He tried to understand what I wanted to accomplish. So my suggestion to you all is that you should do the same. If you've got a building, and let's say it's out in New Mexico, and it shouldn't necessarily just be the same design as those in the neighborhood. Likewise, it shouldn't be the same as the design for your same building that you built in New Jersey. It really needs to be a site specific, and considering not only normal roofing design parameters, but also then your sustainability objectives. So it's really important to us that if we're going to help with design, that we understand your goals. So Target is one of the biggest users of solar in the country, and they have got some really incredibly aggressive goals when it comes to the adoption of renewable energy. So it's important that you know, it's like, let's keep our eyes on the target, no pun intended, but if those objectives are stated, let's try and meet them and meet them well. So this is top left here, you can see where Disney, they actually took our advice and put the solar array on the ground, but you know, 292 acres of solar panels in the shape of Mickey Mouse. So anyway, if you think of the big picture here, how are we going to blend solar and roofing? Is, you know, develop that big picture and long-term thinking mentality. So one of the kind of practices we're implementing at Benchmark, and we're working on it really hard, is kind of a progression, starting with our core values, core focus, you know, then establishing a 10-year target. Where do we want to be 10 years from now? So then a strategy, a 3-year picture, a 1-year plan. And so basically you get down to the bottom of that, and it's like issues. So in other words, how do you solve problems? So what I see happening, unfortunately, when it comes to the issues list, when it comes to rooftop solar, you know, the argument oftentimes starts with the issues. Okay, who's going to own the system or maintain the system? What membrane should we install? How are we going to attach the panels? Are we going to ballast them, mechanically fasten, or use some type of integrated system? And there's really some cool systems out there today. Is there a cover board needed? And then which cover board do we use? So what I think is a trap is that when we start that discussion, focusing on the issues, I think what we need to do is identify what the issues are, certainly identify what the issues are, but then how do we solve them? We got to go back to those core values. What is your company trying to accomplish? Where do they want to be 10 years from today, 20 years from today? This is an opportunity for us to actually align the roof system design. You know, your roof team and your solar team get together and say, okay, what are we trying to do? It's not really that important, you know, who owns it, what membrane, what cover board, you know, is it leased or owned, et cetera. That we're aligning with those values. Then I believe the issues they're just an issue to be solved. A friend of mine likes to say they're just an issue to be solved. And that gives you a good way to go about solving those issues. So that wraps it up. We've got time for some Q&A. Some of the questions, one of the questions that came in had to do with attachment of panels on residential application. And I should say that Benchmark does not do any residential work. So I apologize for that, not necessarily being a great resource, and we can try and identify a resource for you. But when it comes to attachment of the panels, certainly it's an important consideration, something that needs to be very well thought out, and probably involve, you know, a code official in terms of your local jurisdiction and wind uplift areas. Okay. Oops. So we've got a few, some of the, one thing I should state is that we'll follow up with everyone if we don't get to all of the questions offline, and then sending the email, an email recording of the webinar. So, well, thank you very much for participation.